So in lesson 29, we are going to begin something that we call the unit circle. And we are also going to be talking about certain angles that are quadrantal angles. And I'll give you those definitions on that. To begin with, let's start with something that we already know. Our first circle is going to be the angles given in degrees going in the positive direction. So this is something you can probably fill in pretty fast. We know we always start over here at the positive x-axis, so that's 0. And when we're doing vectors or anything like that, we're going around up and to the left. We know when we get up here to the top, that's 90 degrees. How many over here on the left? What about down at the bottom? Those 4 places, by the way, will be what we call quadrantal angles in a minute, just the ones that are on the axes. We've also been working with our special right triangles, and we know that for 30, 60, 90, we can get exact values. They may have square roots in there, but we know how to do that with right triangles, and for 45 degrees. And we've also seen all students take calculus. We can do bigger angles, and we just figure out where those put us, still using these same multiples, so that this is 120, this is 135, this is 150, this is 210, 225, 240, 300, 315, 330, and when we get back to the starting place, that's also 360 degrees. Do be sure you remember your degree signs on these. It's going to be another way of measuring angles, and if we don't have a degree sign, it means we're talking about other kind of measurement. So next one is just as easy. We're just going to do the angles going around in the negative direction, again using degrees. So we're going to have 0 degrees, negative 30 degrees. The negative simply means we go down and to the left as we start out. So negative 45 degrees, negative 60 degrees, negative 90 degrees, negative 120 degrees, negative 135 degrees, negative 150 degrees, negative 180 degrees, negative 210 degrees, negative 225 degrees, negative 240 degrees, negative 270 degrees is up at the top, negative 300 degrees, negative 315 degrees, negative 330 degrees, and when we are at negative 360 degrees, we are also back where we started. Now for most of these, using all students take calculus, we've already figured out, oh, we can figure out the sine, the cosine, the tangent of almost all of those. For example, if I just want to think about the sines, I'm not going to worry about the cosines right now. We'll worry about those another day for the most part. We'll do a little bit today, but mostly we'll just do sine today. We know in the first quadrant, everything's positive, right? Now don't draw all of these triangles that I'm about to start drawing. You may want to do one, but I'm going to draw and erase, and you don't want to get your circle too terribly messy. I know if I wanted to talk about 30 degrees, what I did the other day, oh, I could do my 30-degree angle right here, and I could draw my right triangle there, and I could label my sides with the 1, the 2, and the square root of 3 for my reference triangle. What is for sine opposite over hypotenuse, everyone? 1 over 2. So if I am at 30 degrees, and I just want to talk about the sine of 30 degrees, it would be positive 1/2, what we did the other day. If I wanted to do 45 degrees, I'd be right here. And so if I drew my reference triangle in there, I would have 1, 1, and the square root of 2. Now when I do for my 45 degrees here, when I do opposite over hypotenuse, I get 1 over root 2, but I can't leave root 2 in the denominator. So if I rationalize that, I would have root 2 over a regular 2. If I did 60 degrees, so that I was like this, and I draw my right triangle, put in my reference, my ratios for my reference sides, 1, 2, and the square root of 3. Now what is opposite over hypotenuse, right? So what I've put down here on my circle so far is that the sine of 30 degrees is a half. The sine of 45 degrees is root 2 over 2. The sine of 60 degrees is root 3 over 2. Now, here's where I'm going to run into problems, and we're going to have to do something a little bit different today. If I tried to talk about 90 degrees, so I'm right here, and I tried to draw a right triangle, I've really just got a straight line segment on top of itself. So I can't do right triangle trig there. So in a few minutes we're going to do that one a different way. We're going to figure out, well, what is the sine? What is the cosine when I am on that axis like that? From what we did the other day, when I go into quadrant 2, all students take calculus. Since I'm doing sines, are the sines going to be positive or negative in this next quadrant? Positive. So I could go through and do all of those triangles again like I just did. And get the positive root 3 over 2, positive root 2 over 2, and a half. So for example, I might have this triangle in here with 1, 2, and the square root of 3. And the third quadrant is sine positive or negative. All students take, so sine is going to be negative there, and I get those values. Fourth quadrant, all students take calculus, is sine positive or negative, and I would get those values. And you could go in and draw any of those triangles you wanted to verify that, but with the same ratios of sides, you get those same three basic numbers, a half root 2 over 2, root 3 over 2, positive in some places, negative in other places, but those are really the only choices that you're going to come up with. Okay, to get us started thinking about those missing ones, the ones that are missing on the axes, because I can't draw a right triangle with that as one of the sides on there. So those missing angles are what we call quadrantal. It just means the ones that are on the axes, these 0, 90, 180, 270, 360, 450, negative 90, negative 180. Anytime you land on an axis, that's a quadrantal angle. And we have to figure out sine, cosine, and tangent differently than using right triangle trig. And that's one of the big new things out of today's lesson. So quadrantal, just ones that are on the axes. So we know from what you already did, and you don't need to copy this down again, we're simply talking the 0, 90, 180, and 270 degrees, and we're going to try to fill those in. To do that, we are going to talk about a special circle where the radius is going to be 1. Now notice when I did these triangles to figure these out and fill in the ones we already know, for this one right here, I said my radius was the square root of 2, but when I drew this one over here, I said my radius is 2. So I've got one circle there, and I was labeling two different kinds of radius measurements. And that couldn't really happen in the same circle, but sine is a ratio. For 30 degrees, it doesn't matter how big or small my similar 30, 60, 90 degree triangle is, I'm always going to get the same ratio when I simplify opposite over hypotenuse. So it's okay to draw it with the sides we're used to, and change it when it's these special ones. But when it's other ones, it's going to be, when it's not 30, 45, and 60 degrees, it's going to be more helpful if we think about a circle that has a radius of 1. So if I pick any angle, and that kind of looks like 30 degrees, but let's suppose it's really 28 degrees. We don't have a special right triangle we can use for that. We do know, oh, well, if I draw that line, there's some point where it intersects the circle. And any point I want to talk about has 2 coordinates. First one's x, second one's y. And that's all I've got up there so far. But from what we know about how the coordinate plane works, that means this distance has to be x in order for that first coordinate to be x. That's just how far across I go. The second coordinate is how far and which direction do I go vertically. So that would be y. If the radius is 1 there, then I can say that the sine of that angle is opposite over the hypotenuse, which is y. So I have just said, if the radius is 1, so that's what I'm plugging in here, then this second coordinate is the same thing as the sine of that angle. And if I wanted to do the cosine of theta, that's going to be my adjacent over my hypotenuse. If the radius is 1, that means x over 1, which is just x. So as long as I'm talking about a unit circle with radius 1, x is the cosine of the angle. So the first coordinate is the cosine of the angle. The second coordinate is the sine of the angle. If I wanted to come around to here, whatever this angle is, let's call it, I'll call it beta, just to have something different in there. That means if the radius is 1, whatever that coordinate is would be the cosine of beta, comma, the sine of beta. Thumbs up? Making sense so far. And what helps me remember this? Alphabetical order. X, Y is alphabetical, cosine, sine is alphabetical. So what that's going to mean and how that's going to help us out, if I am at one of these quadrantal angles, so if I am, say, right here, if the radius is 1, that means this is going to be the cosine of that angle, comma, the sine of that angle. If that's 180 degrees, if the radius is 1, who can tell me the x and y coordinates at this point right here that I'm pointing to? He doesn't get through all the work. Somebody else.
-1 and 0?
-1, 0. So that's how we're going to define these for those quadrantal angles. If we're on a unit circle, radius is 1. What are the first and second coordinates at those quadrantal angles? So starting to put that down, if I'm at 0, I'm at 1, 0. So the cosine of 0 is 1, and the sine of 0 is 0. Tangent. That one's going to be a little bit more of a challenge. Let's come back to that last picture. So coming back to my original triangle up here where I had my x, my y, and here was my theta within the circle. If I wanted the tangent of that angle, it would be y over x, right? Opposite over adjacent. But y is also the sine of the angle, and x is also the cosine of the angle. So another definition for tangent, if we aren't in a right triangle, tangent is also sine over cosine. It is not okay, other than scratch work, to ever just write what I said, sine over cosine. It is also not okay to say sine over cosine of theta. You must, when you say the tangent of theta, it's the sine of the angle over the cosine of the same angle. You've got to write the theta both places. It's okay to say, especially as we get into proofs, sine over cosine out loud. It's okay to jot that down if you're just trying to come up with an idea, but it's not okay to put it in the work you're actually turning in that's written down. And the more I say that now, the sooner it will start to sink in. So now if we come back to what we were just asked for, tangent needs to be the sine of 0 over the cosine of 0, or as long as we're on the unit circle, so the radius is 1, which means these are our coordinates, it's going to be the y over the x for right there, so 0 over 1, which is just 0. And another day we'll do a tangent circle where we do the 0 there, and then we do what's the tangent of 30 and a 45 and 60 and 90. But not today. We've got more than enough to do today with basically just the cosine. If I'm up at the top of the unit circle, my coordinates are 0, 1. Cosine is the first one, so the cosine of 90 is 0. The sine of 90 is 1. And then when I try to do the tangent, and I try to do the y over the x, or the sine over the cosine, I get 1 over 0. But we know that does not work to have 0 in a denominator ever. So at the top of the unit circle, at 90 degrees, negative 270 degrees, whatever measurement gets us up there, you can't talk about a tangent with that stuff. We already put up, if we're at the 180 degrees, we're at negative 1, 0, so the cosine of 180 is negative 1. The sine is 0. The tangent is the y over the x, the sine over the cosine, 0 over negative 1, which is simplified to just 0. And finally, if we were at the bottom of the unit circle, again, as long as the radius is 1, these coordinates are 0, negative 1, so cosine is 0, sine is negative 1, tangent is negative 1 over 0, which is undefined. Well, I'm going to have them all up here on this other one in just a moment, because we're going to fill it in on that circle that you have on your yellow paper. Because so far, you've only been using 3 circles on the yellow paper, 1 for degrees in the positive direction, 1 for degrees in the negative direction, and 1 just for the sines. So going back to the 1 for the sines, what we have now figured out is that the y-coordinate here is 0, and the y-coordinate here is 0. The y-coordinate here is 1, and the y-coordinate here is negative 1. So those are the sines for all of these angles. Now think about this. Sine is your y's. So right here, y is 0, right? Doesn't it make sense that at 30 degrees and 150 degrees, they have the same y? We've gone from 0 up to a half. Now at the 45s, I'm going to go up a little bit more. My y's are now root 2 over 2. At the 60s, I go up a little bit more. Root 3 over 2 is even bigger. The biggest one of all is 1. Those are my y's. Same thing when I go down. I go down to the smallest of those negatives, and the next negative one, the bigger negative one, and the biggest negative one is negative 1 itself. So you've got those 3 circles filled in. We'll do the other 5 at other times throughout this semester. What you're going to see as some homework problems will be things that look kind of like this. So starting with the 270 and the 90, those are quadrantals. You can't draw a right triangle and figure those out that way. So for these two, we have to think about that unit circle. And so we just did the sine circle, telling us that at 270 degrees, We're down at the bottom of the unit circle. The y-coordinate, the sine, is -1. So we can say that this is -1. Cosine we didn't write down on the unit circle, but we did write it down on that other page for the top, that the cosine is going to be the x-coordinate right there. The cosine for 90 degrees is 0. So we can write that one down. For 30 degrees, you have a choice. You may do what we've been doing, just draw some 30, 60, 90 triangle, label the sides with the ratios you've been using for the last couple of years, and sine is going to be opposite over hypotenuse, so that is a half. Or, you could be doing what we just did. If the radius is 1, then we have this ratio where this is √3/2, and this is a half, and the y-coordinate is a half, and from the unit circle, the sine of 30 degrees is a half. So you've got a choice there. Same thing for 330. You can say, oh, I'm in the third quadrant. I can draw that. I know sine has to be negative there. I can do the 1, 2, and √3, and I can say that the sine of 330 is therefore -1/2. Or I can think about it on my unit circle, where I let my hypotenuse be 1 instead of 2. The sine is -1/2, and I can write that down so the halves simplify, and my final answer there is -1. We will get to where we memorize everything on the unit circle, so you can very quickly say, oh, this angle means I'm right here, and the x-coordinate is this, and that's what I write down for the cosine at that point in the problem, so you can do it really fast that way. We're not there yet. Right now, you've kind of got a couple of tools. We're stressing understanding, knowing those ratios. I will warn you before we get to them, but we will start having quizzes where I say, okay, what's the sine circle? And I give you a blank one of these, and you have to put all those numbers around it. Or I give you one and say, what are the degrees in the negative direction? And you have to fill all of those out. But I'll warn you before the first one, so don't worry about it yet. Later on, I won't announce when we're having the unit circle quizzes. But for right now, we're just trying to get to the understanding of what's going on.